Here we have a question on polynomials where we have a function fx which is a cubic polynomial, and we know the values of f on some inputs which are f1 is 1, f2 is 2, f3 is 3, f4 is 10, and we need to find the value of f5, which means we need to find the value of that polynomial. So let's save this f5 somewhere else. We need to find the value of f5, right? Now let's check out the values again. f1 is 1, f2 is 2, f3 is 3. Till now it is going linear, but f4 is 10, which is quite explainable because it is given that fx is a cubic polynomial. If we had f4 is equal to 4, then we had concluded that f is not a cubic but a linear polynomial, but we have f4 is 10, so that we are safe. Now first thing, that you know that f is a cubic polynomial, and a cubic polynomial is written as, suppose you have a cubic polynomial fx, it will be written as ax cube plus bx square plus cx plus d. It is a general structure, you can say, of a cubic polynomial. Here we have a cubic polynomial. Why? Because here in the equation the degree is 3 and this equation is in x, an equation or polynomial in x. So here we have 4 variables a, b, c, d. I know x is also a variable, but we know the values of x. If we put f1, if we put x equal to 1 in this equation, you will get a plus b plus c plus d is equal to f of 1. F of 1 is given as 1. Now similarly, if you will put x equal to 2, you will get 2 8a plus 4b plus 2c plus d is equal to f of 2 is 2. And similarly, you can create 2 more equations with the help of f3 and f4, and eventually you will end up with 4 equations in which there are 4 variables a, b, c, d. Now there are 4 variables, 4 equations. You can simply solve the equations. You can pick any 3 equations, or you will pick all 4 equations and you will eliminate one of the variable. After eliminating one of the variables, suppose you eliminated d, then you will get 3 equations in 3 variables. Suppose you eliminated d, so you will get 3 equations in a, b, c. And similarly, you will eliminate all the variables. Eventually you will end up with a single variable, and after solving that equation you will get the value of that variable. Then afterwards, when you will back propagate, you will eventually find all the values of a, b, c, d, and you will find the value of f of x, which is the cubic polynomial. So it will be a simple approach, quite lengthy, but again not that kind of theory or any tricks applied. So that's one way. But if you get this question in a competitive exam or in that type of environment, suppose you don't have this equation. Suppose I gave you fx is a 4-degree polynomial, fx is a biquadratic polynomial, and suppose if I gave you f1 is 1, f2 is 2, f3 is 3, f4 is 4, and f5 is something, and you are being asked f of 6, find the value of f of 6, then what? Then again, will you make all those 5 equations with 5 variables and solve for every 5 variables? No. So the trick behind this question is quite simple and interesting, I must say. So you have a function fx which is ax cube plus bx square plus cx plus d, fine. And you saw this pattern, f of 1 is 1, f of 2 is 2, f of 3 is 3. So let me write one thing, that can we write fx as simply x, fx is equal to x. Now I can write it as fx is equal to x, but it is incomplete because fx is a cubic polynomial, but here we have a linear. It will satisfy f1, f1 is 1, f2 is 2, f3 is 3, but f4 will not be 10. And how I will change this function a bit, I will try to add some term, some big term, for which this term will not affect f1, f2, f3. f1 will be 1, f2 will be 2, and f3 will be 3, which means when putting x equal to 1 in this term, it will get 0. When putting x equal to 2, this term will again get 0. When putting x equal to 3, this term must also get 0. Hence, we need an equation whose roots are 1, 2, 3. Suppose you put fx equal to x plus some function of gx, then you want this gx to be 0 on 1, 2, 3. Now, there is one thing that it is not always true. You also can have a function fx in which when you put x equal to 1, you have put x equal to 1, you have some value here beside 0, but in that case you will not get f of 1 is equal to 1 again. Suppose you put x equal to 1 in this equation, f of 1 is equal to 1 plus some g of 1. If g of 1 is non-zero, then you will not get f of 1 in any case. You have 1 plus some non-zero value, so it will not be 1 again, which means that the condition will not satisfy simply. Now you have fx equal to 1 plus x, fx equal to x plus some gx, and you want this gx to become 0 on 1, 2 and 3. If you want this gx to become 0 on 1, 2 and 3, you know that gx is a cubic polynomial again with the roots 1, 2 and 3. On x equal to 1, on x equal to 2 and on x equal to 3, this gx is becoming 0, which means gx is something like x minus 1 into x minus 2 into x minus 3. So let's replace this gx with the cubic we are talking about, x minus 1, x minus 2 and x minus 3. This is our fx. Now here, this is not the only polynomial, this is not the only cubic polynomial which will satisfy the values 1, 2 and 3. And a next polynomial or a general polynomial can be this also, a times x minus 1 into x minus 2 into x minus 3. This polynomial will also satisfy x equal to 1, 2, 3, but this is again the different polynomial. We are talking here with a equal to 1, and here it is a general polynomial. So upon if you simply open this bracket or solve this polynomial to make an equation, you will get a coefficient of a in every term, but it will still satisfy x equal to 1, 2, 3. Here also, if you take a, if you write a, the equation for f of 1, f of 2 and f of 3 will all again satisfy. For 1, 2, 3, this equation will again satisfy, but now we will use our fourth information, which is f of 4 is equal to 10. Now if you put f of 4 is equal to 10 in this equation, you will end up fx equal to 10, which is equal to 4 plus a into 4 minus 1 is 3, 4 minus 2 is 2 and 4 minus 1 is 1. Now it will be 6 is equal to a times, it will be 6, so a is equal to 1. Now we got the value of a which is 1 using the fourth equation, and using all these three equations we found some structure for fx, which is a cubic polynomial, and it makes sense because it is indeed a cubic with the degree x to the power 3. So in previous case we made 4 equations with 4 variables, but in this case we made a single equation with a single variable, and the finding of this single variable was quite easy also, you just saw. So our a is equal to 1. Now let me rub this and focus on the polynomial, our final polynomial. So our final polynomial is fx is equal to x plus a times a is 1, so 1 times x minus 1, x minus 2 and x minus 3. Now here we have a cubic polynomial, and you can simply solve this cubic and make an equation, make an cubic polynomial, the standard structure, and you can simply find the value of f of 5. We need the value of f of 5, right? Value of f when x equal to 5. But in case of any competition, you can simply put x equal to 5 in this equation only and calculate the value of f. So let me simply put x equal to 5 in this equation. You will get 5 plus 5 minus 1 is 4, 5 minus 2 is 3, 5 minus 3 is 2. So f of 5 will be 5 plus 4 into 3 into 2. 4 into 3 into 2 is 4 factorial, because We don't have 1, but we can write a 1 or just simply remove it. 4, 3, 2 is 24, 24 plus 5 is 29. So our answer is 29. For the 12 is 24, 24 plus 5, 29. So f of 5 came out to be 29. So this was the trick, quite a trick I would say. You can apply these type of things in any question. For example, if you have f of 1 is equal to 1, f of 2 is equal to 4, f of 3 is equal to 9. So you can write again it as f of x equal to x square plus some function gx. What will happen after that? You can calculate the value of gx. Why? Because f of 1 is 1 square plus g of 1. Now this g of 1 must be 0. Similarly, f of 2 is equal to 4 square. Now g of 2 must be 0. So similarly, you will end up thinking about some cubic polynomial which will satisfy 1, 2 and 3. And using this value, you will calculate the value of a. You will set a polynomial a times x minus 1 into x minus 2 into x minus 3. And in this equation, you will end up finding the value of a. So eventually, you will end up the cubic polynomial which satisfies these 4 values, and you will find the 5th value or any value which is given for you in the question. So it was a simple question, simple approach with an interesting idea, with an interesting core idea for it, and I wanted to tell you this idea through a question. So tell me how was the video, comment down below, and if you want to know, if you want to share this video, you are most welcome with your friends. Like this video, subscribe to me, and thank you.